Hi friends, so here I am going to solve the third problem on the damped vibration. Previously I have uploaded the two problems on the damped vibration. This is the third one. Okay, so just read out the problem statement, then we'll see how to solve this problem. Okay, this problem is on damped vibration. So given. So whatever the given, I am going to write here. The vibration record of a spring, mass and dashpot system. See, here they have provided that spring, mass and the dashpot system. The dashpot is nothing but the damper. Means this dashpot is nothing but the damper. So they have given spring, mass and damper system shows the following data. Amplitude on second cycle. So I will draw the graph. Okay, for damped vibration. This one is x0. This one is x1. This value is x2, this one is x3. So what they have given, the amplitude on second cycle. So see, amplitude after first cycle is x1 and after second cycle is x2. Means they have given the value of x2 amplitude after second cycle, and that is equal to 1.2 centimeter. And amplitude on third cycle. So the next one is x3. So amplitude on next cycle, that is third, is 1.05 centimeter. Okay. Now the spring constant for this system means K is 8 Newton per centimeter, and weight attached to the spring, and the weight of the spring is 2 Newton. Now I'll make some changes in the given as per the requirement. See, they have given the value of K in centimeter, so convert it into meter. So how to convert? The centimeter is in divide, so multiply by 10 raised to minus 2 in the division, so that it will be converted into meter. Means 8 divided by 10 raised to minus 2 will be Newton per meter. So ultimately 8 into 10 raised to 2 Newton per meter. Transfer this 10 raised to minus 2 on upper side, so it will become 10 raised to plus 2. So 8 into 10 raised to 2 Newton per meter is the stiffness. Similarly, instead of mass, they have given the weight. So weight is nothing but mg. So mg is equal to 2 Newton. So divide by g on this side. So m is equal to 2 divided by g is nothing but 9.81. So the mass will be, so I'll put in the calci, so it comes out to be 0.203 kg. Means they have given the mass 2.03. They have given the stiffness 8 into 10 raised to 2 Newton per meter. So I have converted the given values into required units. Okay. Now next one. The weight attached is 2 Newton. Now determine the damping coefficient. Now they have asked to determine the damping coefficient. So we'll have to determine the value of C. Now how to determine this C? When we think about the C, then it comes into the formula. So here I will write the formulae which are required. The formula, in which formula this C is going to come? It will come into the formula of zeta. Zeta is damping factor, C divided by Cc. So if we know the value of C, if we know the value of zeta and Cc, then we will get this C. So to get this C, we will have to determine zeta and Cc. Now, what is the formula for Cc? Cc is nothing but 2m omega n. 2m omega n. In the problem, they have given the value of weight. From that, we have determined the mass. So we know the mass, and the omega n that we can determine by using the formula. Omega n is nothing but root k by m. So by using root k by m, we'll get the value of omega n. So I'll write here root k by m. Now just check the value of k and m is given or not. Yes, they have given the value of k, they have given the value of m. So from these two we'll get omega n. If I put here omega n, I'll get cc. Then I'm going to put the cc here. So to get the c, we know the value of cc now. So only thing that we will have to determine is zeta. So how to determine this zeta? Zeta is nothing but the damping factor, and this damping factor we can get from one more formula, and that formula is logarithmic decrement. So I'll write the formula for logarithmic decrement. So delta is equal to 2 pi zeta divided by root 1 minus zeta square. So to get this zeta, I'm going to use this formula, but for that we will require the value of delta, and in the problem they have not given the value of delta, but they have given the successive amplitudes. So I'll write one more formula for this logarithmic decrement, that is 1 by n log to the base e x naught by xn. If I put n is equal to 1, then this will become x naught by x1 or x2 by x3. So this is for successive amplitudes, and they have given x2 and x3, and these are the two successive amplitudes. So here we can put the value of n is equal to 1, means we will get the value of delta. Now if I get this value delta, from that delta we will get zeta, from this zeta and cc we will get c. So if I go in opposite direction from these formulas, means in upward direction, solving one by one, we'll get the value of c. Okay, so we'll follow this path. Now the solution. Now to solve this one solution, first determine the logarithmic decrement. So logarithmic decrement. For logarithmic decrement, I am going to use this formula. Delta is equal to 1 by n log to the base e x naught by xn. If I use number of cycles 1, then this will become x2 by x3, means for successive cycles. So the number of cycles is equal to 1. So I have used the successive cycles. Now put the value. So 1 into log to the base e x2. They have given the value of x2 and x3. x2 is 1.2, x3 is 1.05. x2 is 1.2 and x3 is 1.05. See, these two values are given in centimeter, but I have not converted into meter, because when I take the ratio of these two values, their centimeter will be cancelled. Centimeter will be cancelled. So I have taken these two values directly in centimeter. So there is no issue of the unit. Put these values in calculator, you will get the value of delta. So if I solve this one, then the value of delta is 0.133. So there is no unit to delta. Okay. Now we have solved with this first formula. Now I'll put here the value of delta, so that we will get the value of zeta. So I'm going to put it into the second formula of logarithmic decrement. But the second formula of logarithmic decrement is 2 pi zeta divided by root 1 minus zeta square. Okay, now put the values and solve this equation. So here I'll write 0.133 is equal to 2 pi zeta divided by root 1 minus zeta square. So transfer this root here. So 0.133 into root 1 minus zeta square is equal to 2 pi zeta. Now to remove this root, square on both sides. So 0.133 square into 1 minus zeta square. The square and root will be cancelled. So here 4 pi square zeta square. Now multiply with this value into this bracket. So by multiply to first term. So 0.133 square into 1 minus 0.133 square into zeta square is equal to 4 pi square zeta square. Now transfer this value of zeta square on that side. So 0.133 square is equal to 4 pi square zeta square plus 0.133 square zeta square. Now in these two values zeta is common. So if I solve this, then this comes out to be 0.017, and here if I solve this, if I take zeta square common, then it comes out to be 39.487. Now divide by this term to 0.017, and if I take the root, then I will get the value of zeta. So put these values, and the value of zeta is 0.02. Okay, so see, they have given x2, x3. So by using the logarithmic decrement formula, we get the delta, and if I use the second formula of logarithmic decrement, I will get the zeta. Okay, now we have solved with this equation, this one. Now we will solve with this one. So we know the delta, we know the zeta. Now determine the value of omega n, put this omega n so that we will get the cc. So now I will determine the natural frequency. Natural frequency is the second value we will require. So omega n is equal to under root k by m. So I will put the value of k and m. Just check the values of k and m. K is 8 into 10 raised to 2 means 800, and m is 0.203. So the value of k is 800, 8 into 10 raised to 2, and value of m is 0.203. If I solve this, we will get the value of omega. So wait, I am solving. So omega n. So this answer is 62.776 radian per second. So this is the value of omega n. Now we'll put this omega n into the formula of cc. So the next formula we are going to use is critical damping coefficient. So put into the critical damping coefficient. So critical damping coefficient cc is nothing but 2m omega n. So 2 into the value of m is 0.203 into omega n is 62.776. If we solve one, then we will get the critical damping coefficient, and this critical damping coefficient is 25.487. It is Newton second per meter. Okay, so we have the value of Cc. Now we'll go here. We have solved with delta. From that we got zeta. Then we have solved for omega n. By putting the omega n, we got the Cc. Now the final answer that they have asked, that we have to find the C. C means damping coefficient, and for that we are going to use the formula of zeta. So damping factor zeta is equal to, the formula is C by Cc. Now put the value of zeta, that is 0.02. We have determined. We have to determine this value C, and we know the value of Cc here, 25.487. Transfer this 25 on the other side, we will get the value of C, and the value of C is 0.509, and its unit Newton second per meter. So this is the value of C, that is the damping coefficient. So I will quickly revise the problem. In the problem they have given the amplitude for cycle 2 and 3. Along with that they have given the value of K and the value of M. But they have given the value of K in centimeter. So I have converted into meter. They have given the value of mass in terms of weight. So I have converted into kg. Okay. And the formulas that we have used is, to determine the C, we have used the formula for zeta, that is C by Cc. So we will have to determine zeta and Cc. Cc you can determine by using formula 2m omega n, and for omega n they have given K and M. So by using root K by M we will get omega n. And to determine zeta we will require the logarithmic decrement, and they have given the value of x2 by x3. So by using that x2 by x3 we get delta, and from that delta we get zeta. So if you see the path from last formula, we have started till the first formula. So by using logarithmic decrement we got delta, from delta we got zeta, and then we got n omega n, from omega n we got Cc, and by putting the Cc into zeta we got the value of C. Okay, so this is the answer. Thank you.